Chapter 4 Practice Test Number 8. When a 3 kilogram box is pushed with a horizontal force of 8 newtons across a rough, level floor, it moves with a constant velocity. Find the coefficient of kinetic friction between the floor and the box. Okay, I'm going to draw a little picture first just so that I can full screen this thing. I don't have to keep this other window open. So I've got a level floor, a 3 kilogram box. The floor is rough. It's going to get pushed. Let's see. Horizontal force of 8 newtons. Okay. Going to get pushed. Push it. 8 newtons. Okay. And constant velocity. And we want to know what mu k is. That's what we want. Okay. Full screen it. Alright, I'm going to draw a free body diagram first because that's what I do. A 3 kilogram box. I'm just going to call this positive. Alright, so I've got, well, it's being pushed 8 newtons to, well, in my picture to the right. It doesn't actually matter. I'm going to have gravity. So that's mg, which in this case is 29.4 newtons. I'm going to have normal force and friction. Okay. Alrighty. Well, first off, I'm gonna take the easy hanging fruit first. So, let's see. I'm gonna need normal force if I'm doing anything with friction. In fact, you know what? Let's write this down. I know that other way. Oh no, that was the last problem. I know that kinetic friction is mu k times the normal force. Okay, so basically, I want mu k. I'm looking for friction over normal force. That's right. Friction over normal force. So I just need to find friction and normal force. Okay. Well, all right. In the y direction, F net y equals ma y. Okay, well, F net y, I've got normal force up. I've got gravity down equals m. And a is going to be 0 because in the y direction, its acceleration is 0. Also, this box has a constant velocity, so no matter what, acceleration is 0. Well, that means that Fn equals 29.4 newtons. Okay. In the x direction, F net x equals max. I've got 8 newtons to the right minus friction to the left. That's it. Equals 3. If this thing has a constant velocity, acceleration is 0. Therefore, friction is 8 newtons. I go back up here and I plug those in. I get 8 newtons divided by 29.4 newtons. Coefficient of kinetic friction is 0.27. No units. Just 0.27. Okay. Now, in the interest of points, here's how I'm going to allocate them. I'm going to do something a little weird for this. Okay, so, well, 1 for the answer. That's always good. Oop. Okay. We're going to do 1 for plugging these correct numbers in. Basically, if you got that the friction was 8 and the normal force I'm going to give you 2 for getting that it's 29.4. And I'm not going to give you any points for like how you got there, because some of you will actually use Newton's second law to do it, and you should, but most of you won't. Most of you will just be like, hey, those cancel out, so it must be 29.4. So I'm just going to give you 2 points for getting there. there no matter how you got there. Okay, so that's 4. However, I am expecting you to use Newton's second law in the x direction, okay, and for plugging in 0 for acceleration, and for putting in these two forces properly. Okay, that's 2, 4, 6, 8. Then the last one is 2 points for writing down the correct equation somehow for friction. Okay, so that should be 10. Yeah, 2, 4, 6, 8, 10. Okay, if you you might also get your point allocated for this. You might get it down here or something, but it'll be there.